In this video, I'm going to talk about the velocity and acceleration vectors for objects that are thrown at an angle, any projectiles that are shot or thrown. So let's take a look at an example. So I'm going to draw a cliff here. And let's say that I'm on a cliff and I have a baseball or something and I throw it off the cliff. As we've seen in class, the object's going to travel in a parabolic path. So it's going to look something like this. When I initially throw this object, I throw it with a velocity, and the velocity looks something like this. In physics, we use vectors to represent velocities. And what's a vector? Well, a vector is any quantity that possesses a magnitude and direction, like you see here. So the velocity here, I'll say is just 5 meters per second. And that's the magnitude, how fast I throw it. The other piece of information is at what angle do I throw it. So I throw it at an angle here. Let's call it theta. I throw it at an angle. The fact that there's an angle that defines the direction and the quantity of 5 meters per second, which is the magnitude, makes it a vector quantity. Just like an airplane have a velocity in a certain direction, due north, due south, due east, due west. I got to give you a speed, which is the magnitude, and I got to give you direction if I want to tell you exactly how to throw it or exactly which way to fly. At any point in the motion here, I can take a look at the velocity vector. So let's take a look at a point here at the top. At the very, very top of the motion, there's an instant where the velocity vector points to the right only. And there's a point over here where the velocity vector points down on the way down, which makes some sense. So what happened to the velocity vector as it moves through the air? Well, let me take a look at a snapshot of this velocity vector right there. If I draw a close-up of that, that velocity really has a part that points to the right here, this part right here, called the x part, like the x-axis, and it has an upward pointing part right here called the y part, or the y component. So when I throw this thing at 5 meters per second at a certain angle, I'm actually throwing it to the side, which makes sense, and I'm giving it an upward push as well, so it has two parts of the velocity. Now, as you all know, when I throw this thing, it'll level off and then come back down. So there's a certain point in time where this vertical part disappears, and I only have this x part, or the horizontal part. And then as I let the ball go even further, it points down, and if I draw these x and y parts, I'll see that I have an x part that points this way, and I have a y part that points this way, called a vx and a vy, the y parts of the velocity. So what happened was, this upward pointing part went to 0 as it went up. It slowly decreased to 0, and this velocity in the x direction maintained its magnitude. And then as I went down, instead of an upward pointing Vy, it's now a downward pointing Vy. So what happened there? Why did that occur? Well, that's because of acceleration. There's an acceleration here, a special one called g, which is negative 9.8 meters per second squared. And it's the gravitational acceleration. All objects undergo this acceleration. Negative implying downward, and it's also a vector. So what happened was, as this object moved through the air, this downward pointing acceleration made this velocity vector smaller and smaller and smaller and smaller and smaller, and eventually made it 0. And on the way down, made the velocity vector on the way down bigger, bigger, and bigger and bigger, which is the object speeding up on the way down. The thing to note here is that this gravitational acceleration, g, points downward. It has no effect on sideways motion. The fact that it's traveling sideways is not affected by the gravitational acceleration. Gravitational acceleration only affects upward and downward motion, as you'll probably see in a demo in class. So, bottom line, in this little tutorial, a vector is any quantity that possesses a magnitude direction. Velocities and acceleration are two examples of vectors. Vectors can have two parts. They can have an upward part and a sideways part, as you can see here with the velocity. And as in this example, as the projectile moves through the air, the velocity vector in the y direction decreases, and then on the way back down it increases or speeds back up. And thirdly, we have gravitational acceleration, which is a vector quantity as well, and that acceleration points downward at all points in time. Over here, when it initially leaves my hand, over here, it always points downwards, which is why things slow down, because this opposes the velocity, speeds it back up on the way back down. So there's a qualitative view of vector quantities for projectile motion.